So today, we're diving into something that, let's be honest, can feel a bit like a maze the first time you look at it, the Linux file system. Instead of just seeing this chaotic jumble of letters staring back at you in the terminal, we're going to unpack how this is actually a super elegant, highly structured system. By the end of this tour, you won't just know where things are, you're going to understand exactly why they're there.
All right, to get started, let's address the elephant in the room, the biggest paradigm shift if you're coming from a Windows environment. We are all so used to looking for the C drive, right? Or maybe a D drive. It's a mental model deeply ingrained in how we navigate files. But in Linux, that drive letter concept simply doesn't exist. No way, not a thing.
So the crucial point here is this fundamental difference in architecture. While Windows relies on this disconnected multi-drive paradigm, a C drive for your system, a D drive for games, an E drive for a USB stick, Linux uses what we call the single root tree. It's represented by just one single /. Think of it like the thick trunk of a massive tree. Every single file, folder, application, hard drive, and even a plugged-in USB device eventually becomes just another branch on this exact same tree. It doesn't matter where something is physically stored, its path always starts right here, at the root.
To make sense of this giant tree, we're going to map out the specific branches. We'll start with users and workspaces, move on to the system toolbox, then settings, logs, and temp. After that, hardware and virtual files, and we'll wrap it all up with navigating by purpose.
First up, users and workspaces, where personal files and admins live.
Diving into this very first branch, the directory you're going to be using almost every single day is called /home. If your username is John, your personal workspace is usually going to be /home/John. This is where all those familiar folders live, your downloads, pictures, videos, your personal projects. The absolute brilliance of this setup is that every single user gets their own dedicated home directory. It keeps your personal files completely and securely walled off from anyone else using that system.
Now, right next door, there's a really fascinating distinction we need to make. There's a folder called /root, and man, this one easily trips people up. It is not the base of the entire file system. Remember, the base of the file system is just that single /. The /root folder is actually just the personal home directory for the administrator account, also known as the root user. So, regular users live in /home, and the superadmin lives in /root. Simple as that.
Let's move on to part 2. The system toolbox, programs, binaries, and shared resources.
Let's crack open this toolbox and see how this actually builds the system's functionality. When we talk about programs in Linux, we're usually talking about binaries, and that brings us straight to the /bin and /sbin directories. The word bin literally stands for binaries. The /bin folder, that's your essential toolbox. It holds the basic command line programs Linux needs literally just to function. Commands to list files, copy them, move them around. Without this folder, your system would basically be useless. And right alongside it is /sbin, where that S stands for system. This is the administrator's toolbox. It's packed with commands for networking, disk management, and booting. Regular users aren't going to touch /sbin much, but sysadmins, they live and breathe these tools.
Here is another great mythbuster for you. You are inevitably going to stumble across a directory called /usr. Naturally, you look at that and think, user, right? But it actually stands for Unix System Resources. You should really think of /usr as the main software library for your Linux machine. This is where most of the software you install actually ends up. Applications, documentation tools, the whole shebang.
Of course, all those applications in USR actually need code to run, which brings us to lib. This folder holds shared libraries. Think of libraries like shared building blocks or reusable pieces of code. So instead of 10 different programs installing the exact same chunk of code just to draw a window on your screen, Linux stores that functionality exactly once in the lib directory. Then, all 10 applications just borrow it when they need it. It's an incredibly elegant solution that saves a massive amount of disk space and makes updating your system software so much easier.
All right, on to part 3, settings, logs, and temp, the dynamic and configurable parts of Linux.
Transitioning away from that static software and moving into the highly dynamic parts of the system, we find etc, etc. You can basically think of this as the global settings menu for your entire operating system. Instead of hiding configuration files deep inside individual application folders, like some other operating systems tend to do, Linux beautifully centralizes them right here. Whether you want to change your network settings, configure SSH for remote access, or tweak DNS settings, you are going to do it inside etc.
Next up is a directory that is an absolute lifesaver, var.
Now, var stands for variable. This folder contains files that are constantly growing and changing while the system runs. We're talking system and application logs, email queues, databases, cache files, you name it. And because it holds all the logs, var should be the absolute first place you check when troubleshooting. If something breaks, the exact explanation of what the system was trying to do is almost certainly written down in a log file inside var.
Rounding out this section is /temp, which, as you might have guessed, is for temporary data. Running applications create files in here on the fly as they work. But here is the absolutely crucial takeaway. Many Linux systems automatically wipe this directory completely clean during a system reboot. So whatever you do, do not store any important documents or files in /temp unless you are entirely okay with them vanishing into thin air the very next time you restart your machine.
Moving to Section 4, Hardware and Virtual Files. How Linux interacts with the physical machine. This is where we see how that single root tree structure we talked about brilliantly handles the physical components of your machine. Remember earlier when we asked where a D drive or a USB stick goes? Well, here's your answer. They go into mounting points, specifically the /media and /mnt directories. When you plug in a USB drive or insert a DVD, modern Linux systems will automatically mount it right inside the /media directory. The /mnt directory serves a pretty similar purpose, but it's usually reserved for system administrators who are manually mounting hard disks or network drives. So, instead of assigning a whole new drive letter, your external storage simply sprouts out as a new branch on these specific folders in our existing tree.
Now, what's really fascinating here is the dev directory. In Linux, there is this core philosophy. Everything is treated as a file. And I mean everything. Your hard drives, your plugged-in USB devices, your keyboard, your mouse, the printer, they all physically represent themselves as files inside the dev directory. This unified, file-based interface is incredible. It allows programs to interact with highly complex physical hardware using the exact same methods they'd use to read a simple text file. Honestly, it's the secret sauce behind Linux's legendary flexibility.
Then we have proc, which, honestly, is a bit of a mind-bender. This fascinating folder doesn't actually exist on your hard drive at all. It's a virtual file system created on the fly by the Linux kernel itself. It acts like a live dashboard, showing the system's current running state in real time. If you want to know exactly what your CPU is doing this exact second, or how your memory is allocated, or what processes are actively running, that live information is being actively generated and read from right within proc.
And of course, absolutely none of this hardware interaction would happen without the boot directory. This folder contains the foundational files that are absolutely required to start the operating system, stuff like the core Linux kernel and your bootloader configurations. Without these specific files stored right here, your machine simply wouldn't have a clue how to turn on and initialize Linux.
Finally, Section 5, Navigating by Purpose, the ultimate Linux file system cheat sheet.
We have covered a lot of ground today, and let's face it, relying on rote memorization of acronyms is tough. Grouping by purpose is just vastly more effective. So here's the core mental model to take away from this explainer. If you want your personal workspace, you go to /home. If you need the core operating system toolbox, you go to /bin. Need to tweak global settings? That's /etc. Trying to troubleshoot an error and need the logs? Head straight over to /var. Want to monitor real-time system performance like a live dashboard? Look into /proc. And if you're dealing with physical hardware devices, you're going to find them in /dev. By locking this simple, purpose-driven cheat sheet into your mind, the entire Linux file system completely stops being a confusing maze and transforms into a highly organized library.
So, what does this all mean? Well, it brings us to a final thought for you to ponder. Now that you've seen the underlying logic behind the layout, how does shifting from memorizing random folders to grouping by purpose change your approach to navigating and troubleshooting a server? Next time you find yourself staring at a Linux command line, don't just think about the random letters. Think about what you are actually trying to achieve, and the file system will guide you right to the correct branch.